So today we have this one of my favorite equation. The question says that find x such that if you put that x in under root x minus 13 and under root x plus 20, the answer is a perfect integer. We can say positive integer also. So now I have just enlarged under root x minus 13 and under root x plus 20 also. Now first of all, the difficult thing is there what the question says. Let us understand that. So first of all, let us see that. So we are just going to understand this by an example. Take an example like under root y minus 5 is there. And as it has been told, find y such that if you put that y in under root y minus 5, the resulting answer is a perfect integer. So I have to put in y such that y minus 5 becomes a perfect square. Why? Let us see that. I will just put y is equals to 14. So when I will put y is equals to 14, it would become under root 14 minus 5. And under root 14 minus 5 means under root 9. And 9 is a perfect square of 3. So 3 square and under root that is equals to 3. So as you can see, I am getting a perfect integer when y minus 5 gives me a square number that is equals to 9. So as it has been told in the original question, put x, we have a variable x over there, put x such that x minus 13 and x plus 20 is a perfect integer. So we have to put the value of x minus 13 in x, we have to put x in x minus 13 such that the resulting answer is a perfect square. So let that answer be equals to m square. Similarly, we have to put x in x plus 20 also. So x plus 20 such that the resulting answer is a perfect square. Let that be equals to n square. Yes, this is the condition we have generated, that x minus 13 should be a square and x plus 20 should also be a square, and we have considered them as the square already, like m square and n square. If here it were a cube, so we were looking for a perfect cube. Here is square, so we are looking for a perfect square. So square and root cancel and we get a perfect integer. So okay, let us move further. From here I can see that x is equals to m square plus 13. This 13 has shifted over here, so I obtain the value of x, that is equals to m square plus 13. Now the value of x obtained over in this I will put over here. So instead of x, m square plus 13 and plus 20, which is already over there, and that is equals to n square. Now I can say 13 plus 20 is equals to 33 n square, as it is minus m square. Yes, 33 is equals to n square minus m square. Now I can see 33 is equals to n square minus m square means n minus m and n plus m. Now what this indicates, that 33 is equals to n minus m, n plus m. N minus m and n plus m are nothing but, if a whole number has been given and it has been expressed as the multiplication of variables, means this and this variables are factor of this whole number. This indicates that only. So here also I can say 33 is a whole number given and it has been factored out as n minus m, n plus m. So let us factor out 33 and we will compare that factors with n minus m and n plus m. So I can say 33 can be factored in two ways. So let it be case 1 over here and case 2 over here. So in case 1 I can say 33 I can factor out as 33 into 1 as it is, and that is equals to n minus m, n plus m. Now we will compare these factors. So I will compare this 33 with this n minus m and 1 with n plus m. So 33 is equals to n minus m and 1 is equals to n plus m. So when I will do so, I have to solve for the value of m and n. We have two equations over here. I will just add this both, so m and m cancel. 2 times n is equals to 33 plus 1, that is equals to 34. So I obtain that n is equals to 17. If n is equals to 17, I will put in either of this equation. So I obtain my m is equals to negative 16. Yes, m is equals to negative 16. Let it be clear. M is equals to negative 16. Yes. Now you must be thinking like 33 we have compared with n minus m, but it could be compared with the other one also. So let us do that also. 33 compared with n plus m. So 33 compared with n plus m and 1 compared with n minus m. So when I will add this both equation, m and m cancel. 2 times n is equals to 34. I obtain the same n, that is equals to 17. But this time when I will put n in this equation to obtain the value of m, I will obtain that my m is equals to positive 16. So as you can see, as we have considered the vice versa of these factors, the value of n was the same, but the value of m has been changed just by the sign negative and positive. So this was the case 1, we have factored out 33. Now the case 2, as we can factor out 33. So 33 in case 2 I will factor out as 3 into 11. Yes, 3 into 11 also gives us 33 in 2 factors. We are lucky because there are two ways only in which 33 can be factored out, 3 into 11 or 33 into 1. So small cases are there. If many would be there, it would be difficult test. So n minus m, n plus m. Again we will compare 3 with n minus m and 11 with n plus m. So let us do that. 3 is equals to n minus m and 11 is equals to n plus m. So when I will add this both equation, m and m cancel, what I get is 2 times n is equals to 14, n is equals to 7. When n is equals to 7, I will put in either of those equations, so I obtain my m is equals to positive 4. Yes. Now let us consider the vice versa, 3 with n plus m and 11 with n minus m. So 3 is equals to n plus m and 11 is equals to n minus m. So I will again add, so m and m cancel, 2 times n is equals to 14, so I obtain my n is equals to 7 as it is, and the value of m is equals to, I will put in this equation, I obtain my 11 is equals to 7 minus m, I obtain that m is equals to negative 4. M is already written, so m is equals to negative 4. Again the value of n has come same, only the sign change is there in the value of n. So we have found the value of n and m, so let us write that over here, that my n is equals to 17 comma 7 and my m is equals to plus and minus 16 from over here, or else plus or minus 4 from here. So these are the values of n and m. 33 was a lucky number because only two ways are there to factor, either 33 into 1 or else 3 into 11. So m and n has been obtained, but we have to solve this question for the value of x. So look over here that x is equals to m square plus 13. So as x is equals to m square plus 13, I can put the value of m and obtain the value of x. So this will require a table because few more values are there. So let us do that over here. So first of all, making a nice table, x and m. The value of m were plus and minus 16, negative 16, positive 4, and at last negative 4 also. Yes, look over here, we have the value of m as plus and minus 16, plus and minus 4, that is positive 16, negative 16, positive 4, negative 4. Now we have to put that in m square plus 13. X is equals to m square plus 13. We have to put the value of m over here to obtain the value of x. So when I will put 16, so x is equals to m square plus 13 first of all. Then I will take 16, so it would become 16 square, that is 256. 256 plus 13 is equals to 269. Yes, so x is equals to 269. And when I will take negative 16, so as you can observe, the variable m has used been as a square. So negative 16 square would be 256 only, and plus 13, that is 269. So value of x on positive 16, negative 16 was coming the same. Now let us move further to the 4. When I will take 4, so 4 square 16 plus 13, that is equals to 29. And same with the negative. Negative 4 square is 16, 16 plus 13, 29. So 29 over here, 29 over here. So finally we obtain the value of x is equals to 269 or else 29. These are the two values of x. So let us quickly put. First, before that, you might be thinking in this also, x plus 20 is equals to n square. So n has been obtained as 17 and 7. So if you put that over here, you will get the same x, that is 269 and 29. So let us put in our under roots and check whether the answer is correct or not. We are getting a perfect integer or not. So x minus 13 was the first and under root x plus 20 was the second. So when I will put 269 first, to 269 minus 13 is equals to under root 256, and that's the perfect square of 16, and that's the perfect integer we are getting. Now let us put that, instead of 269, let us put over here 29. So 29 minus 13 is equals to under root 16, and under root 16 is the perfect square of 4. Yes, so it works on both. X minus 13 has worked. Now let us put in x plus 20. So under root 269 plus 20 is somewhat equals to under root 289, and under root 289 is a perfect square of 17. Yes, we are getting a perfect integer. And now putting 29, so 29 plus 20, that is equals to under root 49, and under root 49 is a perfect 49 is a perfect square of 7, so we are getting a perfect integer as 7. So value of x is equals to 269, and 29 will give us a perfect integer when we put them in x minus 13 and x plus 20 respectively. So if you found this problem interesting, do subscribe to the channel and admit that you were unable to solve this interesting problem by giving a like to the video. In the end of the video, I have shown the whole solution at once, so you can take a screenshot if you want to write in your notebook or show it to your friends. And also, if you have any other way, you can suggest me in the comment section, or else you can DM me on my Instagram. Link is in the description.